Hello everyone, and welcome to Module 4, where we'll delve into the fascinating world of behavioral psychology. This module explores the way behavior is shaped by the nature of stimuli and the reinforcement of particular patterns of behavior. But to start, we're going to be talking about classical conditioning. Before we dive in, let's take a look at Module 3 and test your memory with a couple of review questions. Which of the following is an example of the recency effect in memory? A. Remembering the last few items on a shopping list. B. Forgetting information presented in the middle of a lecture. C. Recalling the first few words from a list presented to you. D. Remembering a particularly unusual or emotional event. The answer here is A. The recency effect refers to the tendency to remember items presented at the end of a list because they were most recently viewed. In memory research, what is the primary difference between recognition and recall? A. Recognition relies on cues while recall does not. B. Recall is easier than recognition. C. Recognition occurs in short-term memory while recall occurs in long-term memory. Or D, recall involves identifying information from a list. The answer is A. Recognition involves identifying information when you see it, while recall requires retrieving information without cues. Great job. Module 3 taught us about cognition, thought, intelligence, and memory. In Module 4, we're shifting gears to understanding how behaviors are shaped and influenced, often without conscious thought. Now, when I think of behaviorism, there's a classic Far Side comic that always comes to mind. Here, you can see one amoeba saying to the other, stimulus, response, don't you ever think? Now, believe it or not, early behaviorists would have argued that thinking doesn't matter very much. They believed that our behaviors are shaped entirely by stimuli, not impacted by internal thoughts or feelings. Today, we're exploring this perspective by diving into classical conditioning, a key concept in behaviorism. In this lecture, we'll start with Ivan Pavlov's groundbreaking work on classical conditioning and explore how associations are formed between stimuli and responses. We'll also look at the key components of classical conditioning, like neutral stimuli and conditioned responses. We'll then explore the importance of timing and order in learning, move into some real-world examples like the Garcia effect, and we'll finish by talking about Watson's famous Little Albert experiment, which will teach us about stimulus generalization. By the end, you'll see how this foundational concept explains behaviors in both humans and animals. So are you ready to explore the world of stimuli and response? Let's begin with the story of Ivan Pavlov. Pavlov was a Russian scientist who, by chance, discovered one of the most fundamental principles of behaviorism while studying digestion. Now, Pavlov initially set out to explore the physiology of salivary glands in dogs, but what he found changed the course of psychology forever. To understand Pavlov's discovery, imagine this. Dogs are in a lab. Their saliva ducts have been surgically redirected to external tubes to precisely measure the amount of salivation. The dogs were harnessed in place to eliminate extraneous movements, and Pavlov's team meticulously recorded their reactions to various stimuli. Initially, they were studying a straightforward biological response, but something unexpected happened. The dogs started salivating before they were given food, sometimes just at the sound of footsteps or the creak of a door. This unintentional discovery laid the foundation for what we now call classical conditioning. Let's break down this stimulus-response connection. In Pavlov's case, he observed that food naturally triggered salivation in dogs. This is a natural, unlearned response. But then, over time, dogs began salivating in response to things that had nothing to do with food, like the sound of a door opening. How did this happen? Pavlov realized that the dogs had learned to associate a previously neutral stimulus with the food. This association caused them to salivate even when no food was present, but when the neutral stimulus was. So he went about designing an experiment to test this process, linking these two things together in depth. To do so, he used a metronome, not a bell as most people tend to think, but this metronome was used as a standard cue that food was coming. Now, in classical conditioning, we'll be using some very specific terminology. To introduce each, we have the neutral stimulus, or the NS, the unconditioned stimulus, or the UCS, the unconditioned response, or the UCR, the conditioned stimulus, or the CS, and the conditioned response, or the CR. So let's take a look at what each of these was in Pavlov's experiment. The neutral stimulus in Pavlov's experiment started as the sound of the metronome because before the pairing, it didn't cause salivation. It was just neutral. The unconditioned stimulus was the food, or in this case, meat powder. Now, the meat powder naturally caused salivation without any learning. The unconditioned response was the dog's salivation. In response to the meat powder, the dog would salivate automatically and in a way that was unlearned. After repeatedly pairing the metronome, or the NS, with the meat powder, the UCS, the metronome became a conditioned stimulus. Eventually, the metronome alone triggered salivation, which now has gone from a UCR, or unconditioned response, to a CR, a conditioned response. Let's do a bit of reflection. Think about your own experiences. Can you identify a neutral stimulus that became meaningful because it was paired with something else? Let's watch an example of how a college student classically conditioned his roommate.
Hey Psych 101 class, I'm David and I'm going to be testing Pavlov's theory of classical conditioning on my roommate Brian. The conditioned stimulus will be the sound effect.
That was easy.
And then I'm going to shoot him with this airsoft gun. He will soon learn the relationship between the sound effect and the shot before he gets too hurt.
That was easy. That was easy.
Ah!
That was easy.
Fuck.
That was easy. That was easy.
Alright guys, looks like Pavlov's theory worked.
Now, I wouldn't recommend repeating this unless you wanted to get on your roommate's bad side, but it does demonstrate a real-world example of classical conditioning at work. The initially neutral stimulus, the that was easy sound, was paired with an unconditioned stimulus, the airsoft gun, and the unconditioned response, which was pain or anticipation of pain. After several pairings, the NS became the conditioned stimulus, and that conditioned response became flinching. Classical conditioning isn't just about pairing the stimulus and response, it's also about the timing of that pairing. The sequence and timing of when the neutral stimulus, or the NS, and the unconditioned stimulus, or the UCS, are presented play a critical role in determining how effectively an association is learned. Let's break this down by looking at a few different pairing methods. Simultaneous pairing, forward short delay pairing, forward long delay pairing, and backward pairing. In simultaneous pairing, the NS and the UCS are presented at the same time. An example of this would be if the metronome ticked at the exact same moment that food was delivered. In terms of effectiveness, this method isn't that effective because the neutral stimulus doesn't actually predict the UCS, they just coincide at the same time. Next, we have short delay pairing. This is when the NS is presented just before the UCS, with only a short delay between the two. This is how Pavlov did his experiments. The metronome started ticking, and then the food was presented immediately after. This method is the most effective, becomes a reliable predictor for the unconditioned stimulus. Next, we have forward long delay pairing. This would be if the NS was presented long before the UCS. In this example, the metronome would tick, but then the food wouldn't be delivered until several seconds or minutes later. This method is less effective because the delay makes it harder for an organism to connect the two stimuli together. Finally, we have backward pairing. This is when the UCS is presented before the NS. So the example here would be if the food was delivered and then the metronome would tick. This is the least effective method because the NS fails to act as a predictor for the UCS. So why exactly does short delay pairing stand out from the rest? One is it has high predictive value. The close timing makes it clear that the NS predicts the UCS. It leads to stronger associations. The brain can form a stronger connection when one signal reliably predicts another, and it's also easier to learn. The consistent sequence makes it easier for an organism to recognize the relationship between stimuli. Let's do an attention check question. Which of the following pairing methods is generally the most effective in classical conditioning, and why? Simultaneous pairing, because the neutral stimulus and unconditioned stimulus occur together, ensuring maximum association. Backward pairing, because presenting the unconditioned stimulus first ensures a strong response. Forward short delay pairing, because the neutral stimulus provides the unconditioned stimulus by a short interval, providing predictive value. Or forward long delay pairing, because the longer time between the stimuli strengthens learning. The correct answer is C, forward short delay pairing. This method is most effective because the close timing between the NS and the UCS helps the organism to learn that the NS reliably predicts the UCS. Now that we've explored timing and order, let's look at a fascinating twist on classical conditioning, a phenomenon known as the Garcia effect. Unlike most forms of learning, this one can happen after just a single pairing. Let's think about an example. I once knew a student whose favorite snack was goldfish crackers, but then she suddenly came down with a case of appendicitis. Now, unfortunately for her, appendicitis comes with quite a bit of nausea and vomiting. From that day forward, the sight of goldfish crackers, which she had been snacking on regularly beforehand, made her stomach churn because they became associated with the sickness caused by appendicitis. This is the Garcia effect, a unique form of classical conditioning where a single experience is enough to create a strong aversion to certain tastes. Unlike traditional conditioning, the Garcia effect breaks many of the rules that we've just learned. Some key features of this remarkable effect include single trial learning. Now, typical conditioning usually requires multiple pairings of the NS and UCS, but in the Garcia effect, a single pairing of the food, the initially neutral stimulus, and the sickness, the unconditioned stimulus, can establish a lifelong aversion. There is a long delay between stimuli. In typical conditioning, the NS and the UCS are presented within seconds of each other, but in the Garcia effect, hours can pass between eating a food and feeling sick, yet the association still forms. It's specific to taste and smell. The aversion is highly specific to the taste and smell of foods, and it doesn't generalize to other sensory experiences as much, like sights or sounds. And it's highly resistant to extinction. Once learned, taste aversions are incredibly persistent, often lasting a lifetime, even if the person logically knows that the food wasn't the cause of their illness. Why is the Garcia effect so powerful? Evolution provides the answer. For our ancestors, eating something toxic could mean the difference between life and death. Learning to avoid potentially harmful foods after just one bad experience was a crucial survival mechanism. Interestingly, our student's aversion was specific to goldfish crackers, but not to all crackers. This is an example of stimulus discrimination. She learned to associate the sickness with one specific food, but not with others. The ability to discriminate between safe and unsafe stimuli is another survival advantage. Now, the Garcia effect isn't just an academic curiosity. It has real-world applications. Researchers Nicolaus and colleagues in 1983 used the Garcia effect to protect endangered bird eggs from predators, namely crows. The researchers wanted to prevent the crows from stealing endangered eggs. They did this by injecting lithium chloride into some of the eggs to induce sickness. This then taught the crows to avoid eating the eggs altogether, helping them to preserve species populations. The crows stopped stealing the eggs. This is an amazing application of the Garcia effect to help protect the environment. Now, moving on, while stimulus discrimination in the Garcia effect helps us to focus on one specific trigger, classical conditioning also has another side, stimulus generalization. To see this concept in action, we'll explore one of psychology's most infamous experiments, the Little Albert study. Classical conditioning isn't just about salivating dogs and taste aversions. It's also about learning emotions like fear, as we saw in the roommate example. One of the most famous demonstrations of this was with Little Albert, an experiment conducted by John Watson in the early 20th century. A controversial and now clearly unethical study was aimed to show that fear, like other behaviors, could be learned through classical conditioning. In the experiment, Watson worked with a young child known as Little Albert. Let's break it down, looking at the components of classical conditioning and how they played a role. In this experiment, the neutral stimulus, and eventually the conditioned stimulus, was a white rat. Initially, the white rat was neutral. It didn't elicit any specific reactions. The unconditioned stimulus, or the UCS in this case, was Watson introducing a loud, startling noise by striking a steel bar. Now, this caused Little Albert to cry. That was the unconditioned response. The UCR was crying, which for Albert was automatic in response to the loud noise. Watson then paired the white rat, the NS, with the loud noise, the UCS, repeatedly. Over time, Albert began to cry, which was now a conditioned response, just at the site of the white rat, which was now a conditioned stimulus. But what makes this study even more unsettling is what happened next. Albert's fear didn't remain specific to the white rat, or even broadly just to white rats generally. He began to fear other white and fluffy objects, like a Santa Claus mask and a fur coat, even though they hadn't been paired with the loud noise. This is referred to as stimulus generalization, when a conditioned response spreads to stimuli that are similar to the original conditioned stimulus. In Albert's case, his learned fear of the white rat generalized to anything white and fluffy. While the Little Albert study is a textbook example of stimulus generalization, it's also a cautionary tale about ethics in research. Here's why. This study involved a lack of consent. Little Albert's guardians likely weren't fully informed of the study's purpose or its potential psychological impact. It included emotional distress that wasn't really controlled for. Intentionally inducing fear in a child raises serious ethical questions about the researcher's responsibility to their participants, and it led to lasting harm. Albert's fear responses were never deconditioned, meaning he may have carried those learned fears into adulthood. Let's take a moment to reflect. Have you ever noticed a fear or preference that generalized to similar objects or situations in your own life? For example, does a bad experience with one dog make you cautious around all dogs? What kind of evolutionary benefit could stimulus generalization provide? Today, we explored the foundational principles of classical conditioning. We discussed Pavlov's groundbreaking experiments and how neutral stimuli can become powerful triggers for learned responses. We discussed the key components of classical conditioning. We discussed the neutral stimulus, the NS, the unconditioned stimulus, the UCS, the unconditioned response, the UCR, and how the neutral stimulus could eventually turn into the conditioned stimulus, the CS, and the unconditioned response would become the conditioned response, the CR. We discussed the role of timing and order, showing how predictive value strengthens associations. We talked about the Garcia effect, a remarkable example of how biological predispositions can shape learning, as well as how it leads to stimulus discrimination. Finally, we talked about the Little Albert study and stimulus generalization. We also talked about some of the ethical questions that it raised. Classical conditioning isn't just a lab phenomenon. It's woven into the fabric of our everyday lives. From the jingles that make us crave fast food to the fears we develop after one bad experience, these principles help explain how we learn to navigate our world. Let's do some review. Which of the following is an example of the Garcia effect? A dog salivating at the sound of a bell, developing an aversion to shrimp after food poisoning, a child crying when they see a white rat, associating a ringtone with excitement. The answer here is B. The Garcia effect is all about associating taste with sickness, often after just one experience. Next up, in the Little Albert study, what best illustrates stimulus generalization? Albert's fear of the white rat, Albert's crying at the sound of the gong, Albert's fear of all white fluffy objects, or Albert's eventual loss of fear through extinction? The answer is, of course, C. Stimulus generalization occurs when a learned fear spreads to other stimuli. Classical conditioning gives us powerful tools to understand and predict behavior, but it also reminds us of the importance of ethics in research. In our next lecture, we'll continue our exploration of behaviorism with a deep dive into operant conditioning, where the focus shifts from associations to rewards and punishment and their consequences. Until then, stay curious, stay resilient, and above all, live life in flux. Flux out. See you in the next lecture.